test the temperature effects on reaction rate, we have experimented with sodium thiosulfate and hydrochloric acid. And we have 3 different temperatures. We have our ice bath for lower temperatures, hot bath for our higher temperatures, and we just have test tubes for our room temperature. So experimenting out with our low temperature, we're going to be putting hydrochloric acid 2 millimeters into one of the test tubes for low temperature. We're going to be putting 2 millimeters of sodium thiosulfate into one of the other test tube for the low temperature. And we're going to be, we need the temperature of our ice bath, and we're going to record that. And when we record that, and then we can put our test tubes into our ice bath, and we want to record it for stop timer for like 5 minutes. And then immediately after, and then we want to have that handy because immediately after we take it out, we're going to pour our hydrochloric acid into our sodium thiosulfate, and we're going to press the timer, and we're going to see when we're going to stop our timer once our precipitate of sulfur, which will be yellow, when that forms, we're going to stop our timer. And so that concludes for our ice bath. And we can just move that out of the way. And then we can move on with our hot bath. So same thing, 2 millimeters of sodium thiosulfate, 2 millimeters of hydrochloric acid. We forgot we need 1 more millimeter here. And then we want to record our, our temperature. We want to turn our hot bath and record our temperature to 60 degrees Celsius. We don't want it to surpass 65 degrees Celsius, however. And once it has done that, we can remove it without our hot water. Our hot water is at 60 degrees Celsius. We want to put our test tubes, and we want to record it for about 5 minutes. And immediately after we take it out, we're going to pour our hydrochloric acid into our sodium thiosulfate, press the timer, and stop the timer once we see our sulfur yellow precipitate form. And then that concludes for the hot bath. We can move that out of the way. And then we have our room temperature, which we don't need a hot bath just because room temperature. We're going to put our 2 millimeters of sodium thiosulfate, and we're going to put our 2 millimeters of hydrochloric acid, and we're going to press we don't need to leave it for 5 minutes just because this has been already sitting out in room temperature. So once we pour our hydrochloric acid into our sodium thiosulfate, we want to press this timer immediately. And once we see our yellow sulfur precipitate form, then we can stop our timer, and we want to always be recording our temperatures. And we're going to always be recording our time depending on the temperature. And what we want to record this because we can make a graph which we can visualize how the temperature affects the reaction rate for the different temperatures, because at different temperatures, at a higher temperature, for example, the average kinetic energy of the solutions will be increased because of the temperature, which will allow for more collisions to occur. Thus, that'll give you our higher reaction rate, because if more collisions occur, the solution will react more readily. And we can see how at 60 degrees, which is our highest temperature, our reaction rate, the time it took for the reaction rate was about 30 seconds, 31 seconds around there. And we can see at our lowest temperature, that was our highest temperature, was the fastest reaction rate, because the higher the temperature, the more kinetic energy that'll be given into the solution, or what's being reacting, and it'll make more collisions, therefore making the reaction rate faster. In our lowest, which was at the cold water bath, it took 180 seconds. So that's because the molecules aren't moving as fast, and therefore they are reacting slower. And then in the room temperature was in the middle, around 80 seconds, so that's in between just a normal and a natural state.